Find the largest number that divides 2053 and 967, leaves remainder 5 and 7 respectively. So see, let the number be x, and this number divides 2053, which means this x divides 2053 and leaves a remainder of 5. And the same number then also divides 967 and leaves a remainder of 7. So we see that x is not a factor of 2053, but x is a factor of 2053 minus 5. So that would be 2048, and x is a factor not of 967, because you get a remainder. If it's a remainder, then it's not a factor. So it is a factor of 967 minus 7, and which is 960. So to find x, we need to find HCF of 2048 and 960. However, here you got to stop the sum by saying let the number be x. So to find the HCF, we take 2048 into prime factorization. They come 2 raised to 10. And 960 prime factorization is 2 raised to 6 into 3 into 5. And to find HCF, we take common factor. Common factor is 2. There is 2 here, 2. And we take the lowest power, that is 6. And 2 raised to 6 is 64. So the number is 64. And if you divide 2053 by 64, you divide and see, you'll get remainder 5. And if you divide 967 by 64, you get remainder 7. Find the largest number that will divide 398, 436 and 542, leaving remainder 7, 11 and 15 respectively. So is it HCF or LCM? So we know that 398 will divide, so it divide by x. In the first case it gives remainder 7 here. Then we have 436. Here also it is divide by x, and the remainder is 11. And again we have 542 divide by x, and the remainder is 15. So you'll say let the required number be x. So in this first we see that 398 is not the multiple of x. So x is not the factor of 398. Why it is not the factor? Because when you divide 398 by x, the remainder becomes 7. So you'll say x is factor not of 398, but of 398 minus 7, and that is 391. In the second case, we see x is factor of not 436. 436 minus the remainder, that is 11, and that becomes 425. And x is factor of 542 minus 15, and this is 527. Now to find x, you know it is factor, factor, factor. So to find x, we need to find HCF of 391, 425 and 527. So to find the HCF, we do prime factorization. First we take 398. 398 is 23 into 17. Then 425. 425 is 5 square, 25 into 17. And then we have 527, which is 31, not 13. It is 31 into 17. Now to find the HCF, we take what is common, 17, 17, 17 common, and the highest power. So the answer is 17. The required number is 17. Find the smallest number which, when increased by 17, is exactly divisible by 520 and 468. So we'll say let the number be x. Let the number divisible by 520 and also divisible by 468 be x. Now here the question is, do we find HCF or LCM? So they said that this number is divisible by 520. So 520 will come in the divisor side, and the number x is divisible. So this is 468. So here we can say that x is now multiple of 520, and here x is multiple of 468, which means to find x we have to find the LCM. To find x we find LCM of 520 and 468. So to find LCM, you do 520, you do prime factorization of 520, which is 2 cube into 13 into 5. Then 468. 468 is 2 square, 3 square into 13. Now to find LCM, you take all the factors. One factor is 2, one factor is 13, there's a factor 5, and there's a factor 3, and the highest power. Look at 2 has got highest power 3, 13 highest power 1, 5 highest power 1, and 3 highest power 2. So the LCM here works out as 4680. So 4680 is divisible by both, by 520 and by 468. But we want a number that on increasing becomes divisible. So the required number equal to 4680 minus 17, because they said the number on increasing should be divisible. So 4663 is the required number. Let me explain this part again. So when you take 4663, you add 17 to it. This is the required number. We will give you 4680, and this 4860 is divisible by 520 and 468. So the required number is 4663, because they said it has to be increased by 17 and then becomes divisible. In the seminar, the number of participants in Hindi, English and mathematics are 60, 84 and 108. So let me just write that. Number of participants Hindi is 60. Then number of participants for English is 84, and of mathematics is 108. Okay, find the minimum number of rooms required if in each room the same number of participants are to be seated and all of them being in the same subject. Now, is it HCF or LCM? Now, this means if I have the Hindi students have to be divided into many rooms. We don't know how many. Say in each room there are X, X, X. Then when we come to the English, also have to be divided into many rooms. The 84 students have to be divided into groups of X, 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 same number of rooms. And then when it comes to mathematics also, they have to be divided. This 108 students have to be divided in rooms. So let X be the number of students in each room. So in the first case, you see X has to be, in the first case, X has to be a factor of 60. Here also X has to be a factor of 84. And here also X has to be a factor of 108. So we'll say let the number of participants in each room be X. So the Hindi students have XX students in each room. So X is factor of 60. X is also factor of 84. And X is factor of 108. So to find X, we need to find the HCF. Find HCF of 60, 84, 108. So we know 60 is equal to 2 square into 3 into 5. 84 equal to 2 square, 3 into 7, and 108 equal to 2 square into 3 cube. To find HCF, for HCF, we take common factors. Which are the common factors? There is 2 throughout, and there is 3 also throughout. Lowest power. The lowest power of 2 is 2, and of 3 is 1. So the HCF is 12. So in each room there will be 12 students. So in the Hindi students, they will be divided like 12, 12, 12 in each room. The English students also will be divided into a number of rooms, but 12, 12 students in each room. And the mathematics also will be divided into a number of rooms. We don't know how many, but 12, 12, 12 in each room. So how many rooms will be required? First we have to find what are the total students. Now total students will be the students for Hindi plus English plus maths, and that is 60 plus 84 plus 108, so which is 252. Number of rooms required will be 252 over 12 students in each room, over 12, that is 21 rooms. So number of rooms required equal to 21. What is the smallest number which when divided by 35, 56 and 91 leaves the remainder of 7? So what we need to find out is we have to find a number x which when divided first by 35 leaves a remainder 7. The same x when divided by 56 leaves remainder 7, and 91 when x is divided by 91, it leaves a remainder 7. So you'll definitely see here this x comes in the multiple. Whenever there is a division, here we write the multiple and this is the factor. So here we see that that x is a we have to find the LCM here, because we need to find this number, and this number is always multiple. So we go ahead and find the LCM of 35, 56 and 91. To find the number, we need to find LCM. We need to find LCM of 35, 56 and 91. So 35 is 3 into 35 is 5 into 7, 56, 2 raised to 3 into 7, 91 is 7 into 13. Now when we find LCM, we write all the factors. The factors are 2, 5, 7 and 13, and their highest power. The highest power of 2 is, we see, 3. Highest power of 5 is 1, of 7 is 1, and this is 1. So when you multiply, you get here 3640. Now remember, the 3640 is the LCM of, let me write that, 3640 is LCM of 35, 56 and 91, which means when 3640 is divided by 35, you will get remainder 0. If 3640 is divided by 56, you will get remainder 0, because it's LCM. And when the same 3640 is divided by 91, you will get remainder 0. But in this case, you need a remainder of 7. So who will give you the remainder of 7? How will you get remainder 7 here? If you want remainder 7, you got to add up 7 here. So this would be 7 here, right? Same thing here. If you want 7 as remainder. So we see the required number will be 3640 plus 7, because we want a remainder of 7. 3647 is the required number. A rectangular courtyard is 18 meter by and 72 centimeter long, 13 meter and 20 centimeter broad. It is to be paved with square tiles of the same size. Find the least possible number of such tiles. So here is the length. I'll take 18 meters, 72 centimeters. I'm converting it into centimeters. And the breadth is 1320 centimeter. Now this is to be paved into tiles. We're going to put tiles here right through. Now let the size of the tiles side be x. So here you'll have x, 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 x. So you'll definitely agree x has to be the factor of 1320. Here also the size of the tile, the side is the same. It's a square tile, x, x, x. So x also has to be the factor of 1872. So the length of the courtyard is 1872 centimeter. I convert into centimeter. And the breadth equal to 1320 centimeter. Let the side of the square tile be x centimeter. So we have seen here x is factor, it has to be the factor of 1320, and x also has to be the factor of 1872. So to find x, we have to find the HCF. So x is HCF of 1872. So let's go ahead and find the HCF. So we have 1872 prime factorization is 2 raised to 4 into 3 square into 13. And then we have also 1320 prime factorization, 3 into 2 cube into 11 into 15. Now when we want to find HCF, we write the common factors. The common factors are 2 and 3 and the highest power. The highest power of 2 is 3 and of 3 is 2. So that is 8 into, highest power of 3 is 1. So that would be 8 into 3 and the 24. So each of this side is 24 centimeters. So area of one tile equal to side into side, that is 24 into 24, 576. Now how many tiles would we require? To find out the number of tiles, we have to do total area over area of one tile. So this was the dimensions: 1872 centimeter, 1320 centimeter, and we saw that the area of each tile has to be 576. So each tile 576. How many such tiles will we require? So area of one tile is 24 into 24, 576, and total area of the courtyard we know is 1872 into 1320. So the number of tiles required will be total area, that is area of courtyard, over area of one tile, and 1872 into 1320 over 24 into 24, which is 576, and the answer to that comes as 4290 tiles. So this is a sum where you have to find the HCF. Usually when your number is smaller, here the side of the tile is smaller, then you have to find HCF. If your number is larger, you have to find LCM. Find the largest number which exactly divides 280. So we want a number that divides x, divides 280, leaving remainder 4 and 3. So in this case, leaving remainder 4, and the number also should divide 1, 2, 4, 5, leaving remainder 3. By now you guessed our x is here, so we have to find the HCF. But 280, x is not the factor of 280. X is factor of 280 minus 4, and that is 276. X also is factor of 1, 2, 4, 5 minus 3, and that is 1, 2, 4, 2. So to find x, we find HCF of 276 and 1242. Okay, so we have 276 prime factorization, 2 square, 3 into 23. Then you have 1, 2, 4, 2 prime factorization, 2 into 3 cube into 23. When we find HCF, we write the common factors. The common factors here are 2, 3 and 23, all raised to 1, lowest power. That is 138. So the answer is 138. Which means if you take 280 and divide it by 138, you will get the remainder 4. And if you take 1245 and divide it by 138, you get the remainder 3. So the answer is 138. Which is the largest number that divides 226, 3127 and 15,628, leaves remainder 1, 2, 3 and 3 respectively. The largest number that it divides 626, in the first case leaves remainder 1. Then again it divides 3127, leaves remainder 2. And then divides 15628 and leaves a remainder 3. So here again we say x is factor of 626 minus 1, that is 625. X is factor of 3127 minus 2, which is 3125, and x is factor of 15628 minus 3, and 15625. So to find x, we need to find x, we need to find HCF of 625, 3125 and 15625. So when we do prime factorization, 625 is 5 raised to 4, 3125 is 5 raised to 5, and 15625 is 5 raised to 6. So for HCF, we take common factor, that is 5, and take the lowest power, which is 4, that is 625. So this number here is 625. If you divide 6 to 6 by 625, you will get remainder 1. If you divide 3125 by 625, you will get remainder 2. And if you divide 15628 by 625, you will get remainder 3. 2 tankers contain 850 liters and 680 liters of petrol respectively. Find the maximum capacity of a container which can measure the petrol of either of the tanker in exact number of times. So let the capacity of the container be x. X liters. So now remember, 850 has to be measured by x. So 850, you have this little containers, x divided by x, x and x and so on. Then we have another one of 680 liters. 680 liters also has to be divided into the smaller, you're measuring it with a container x, x, x and so on. So you'll definitely agree x has to be a factor of 850 and x also has to be a factor of 680. So x is a factor of 850 and x is a factor of 680. To find x, we need to find HCF of 850, 680. So let's find HCF. So 850 equal to, so 850 on prime factorization, you get this 17. 680 on prime factorization, 2 cube 5 into 17. To find the HCF, we have to take common factors. So the common factors are 2, 5, 17, and the lowest power 1, 1, 1. So which is now 170 liter. So each container, the capacity of the container should be 170 liter. Which means when it takes 850 and you keep dividing it by 170, 170, each container is 170. So you will get here, so you get 850 divided by 170, you get 5 such containers. And the other case, 680, when you divide it by 170, you will get 4 such containers. So the answer is 170.